Every time you type a website address, something invisible happens before the page loads. Your device has to find out where in the world that website actually lives. That's DNS, and it happens in milliseconds every single time. Here's the thing. The internet doesn't understand words. Every server, every website, every device has a numeric address called an IP address. Google's is 142.250.80.46. Netflix is at 54.236.200.177. Facebook is at 157.240.241.35. You'd need to memorize hundreds of numbers just to browse the web. DNS exists so you never have to. Open your phone's Contacts app. Search for Mum. You don't know her number off the top of your head, but your phone does. DNS works identically. You type google.com, DNS looks it up and says, that's 142.250.80.46. Go there. Done. You always use the name, the system always finds the number. Before your query even reaches the internet, DNS checks 3 local places. First, your own device. If you visited Google 2 minutes ago, the answer is already saved. Second, your home router. It keeps a shared cache for everyone in the house. Third, your ISP's resolver, a powerful server your provider runs that handles billions of queries a day. Only if all 3 fail does your query go further. When the resolver needs to find a fresh answer, it works through 3 levels, like finding a house using city, street, then number. Root servers handle the top, who-manages.com. .com servers handle the middle, who-manages-google.com. Google's own name servers handle the bottom. Here's the exact IP. The resolver stitches all 3 answers together and returns it to you. Let's trace exactly what happens when you type netflix.com. Your browser asks your operating system. It checks its local cache. Nothing. It asks your router. Nothing. Your router asks your ISP's resolver. The resolver checks its cache. Nothing. So it asks a root server, gets pointed to .com, asks .com, gets pointed to Netflix's name servers, and Netflix replies 54.236.200.177. Your browser connects. Total time, under 50 milliseconds. Here's something that catches everyone out. When a company moves their website to a new server, DNS doesn't update everywhere instantly. Every cached answer has a TTL, time to live. If it's set to 3,600 seconds, every resolver on Earth keeps serving the old address for a full hour. This is called DNS propagation, why moving a website can take up to 48 hours to reach everyone. At work, you type payroll.company.com and it loads instantly. You get home, type the exact same address, and it says server not found. That's not broken. Your company runs a private DNS server, only reachable on the office network. Same name, completely different result depending on where you are. IT professionals call this split horizon DNS. It's why you need a company VPN from home to reach internal addresses. Most people use their ISP's DNS by default, but you can change it. Google runs 8.8.8.8, one of the most reliable resolvers on Earth. Cloudflare runs 1.1.1.1, currently the fastest. Changing your router's DNS to 1.1.1.1 takes about 30 seconds and can measurably speed up every website you visit. It's one of the simplest performance upgrades anyone can make. DNS stores more than just IP addresses. An A record maps a name to an IPv4 address. That's the most common. AAA does the same for IPv6. A CNAME is an alias. www.google.com simply points to google.com rather than its own IP. MX records tell the internet where to deliver your email. NS records declare which servers are authoritative for a domain. Each record type serves a specific purpose in the system. 4 traps that appear on every networking exam. Can reach by IP but not by hostname. That's a DNS failure. The network itself is fine. New DNS record not resolving. Old TTL is cached. Wait it out or lower the TTL beforehand. DNS uses UDP port 53 for standard queries, TCP port 53 for large transfers and zone replication. And remember, the recursive resolver does all the work. Your device just asks and waits for the answer. Test yourself. A company moves their website to a new server and updates the DNS record immediately. Some users around the world still reach the old server for several hours. What is the most likely reason? That's DNS, from why it exists, to every layer of resolution, to why website changes take time to reach everyone. For more networking fundamentals, DHCP, NAT, routing, subnetting, Courseiva has hundreds of practice questions. We'll see you there.